Hello Service people, Enrico here. In this video I want to go through the S3 cheat sheet document that I have created for the AWS Solutions Architect Associate exam. This document is available on my Twitter profile. I'm going to share it for free. And also on the second part of the video I'm going to go through some S3 exams questions and explain to you my reasoning when I read a question and also when I decide which is the right answer. In this way, you can see tips and tricks on how to, exclude some answers and how to find the right answer based on the questions and based on some details we're going to see on the questions. So let's get started and go through the basic concept of S3. S3 is an object-based storage and files can be from 0 to 5 terabyte. There is unlimited storage, so you can put as much data as you want inside a bucket because files are stored inside bucket. Buckets are by default private, and you have to remember that S3 is a universal namespace, meaning that when you create an S3 name, an S3 bucket, the name must be globally unique. It means that nobody in the world can have the same name for an S3 bucket. When you upload a file into a bucket, this is an S3 object that has different properties. So the key of the object is the object name, which is also the object path. So if you upload the file directly in the S3 bucket or if you add some folders in it, then you have the value, which is actually the object data, so the bytes of which the file is composed of. Then you have the version ID. This is useful when you enable versioning on the bucket and you have different versions of a file. And then we have metadata. So these are like additional data on your object that you can add when you upload the file. Remember that if the upload is successful, S3 is gonna answer to you with a 200 OK HTTP response. Now let's see what is the consistency model of S3. We have two models, read after write and eventual consistency. Read after write is for new objects. So when you upload new objects into an S3 bucket, usually the action is a put action. The files will be ready just after being uploaded. And then we have the eventual consistency, which means that when you overwrite or when you delete objects, you will get eventually the last version of the files. So files can take some time to propagate because of the S3 architecture. As we will see in a minute, S3 is replicated into different availability zone. So it can happen that sometimes you don't get the last version of the file, but this is just in a matter of seconds, and then you're gonna get the latest version of the file, which could be either the uploaded version or a delete. Next concept we need to know for the exam is the versionings plus lifecycle rules. So by default, the versions in the S3 buckets are not enabled. If you enable versioning on S3, once it's been enabled, it can be disabled. So remember that for your exam. It can be used as a great backup tool. So let's say you want to make sure that if by mistake you upload another object or you delete another object, you have all the versions of the object available in the bucket. With the version enable, you can do that because you're gonna have all the versions in your bucket. Of course, these add storage size, so you will have to pay more because you're storing basically different versions of the same file, so be careful for that. And it can be integrated with lifecycle rules. So lifecycle rules, I also made a video about it. I'm gonna add it in the description, and you can basically add rules inside your bucket to move object or to delete objects based on time rules. So let's say after 7 days you want to move your object to, I don't know, S3 Glacier maybe, because you don't need to access this data frequently and you want to pay less in terms of storage. And all these kind of use cases that you need to understand because you're going to be tested on the exam. There are going to be a lot of scenario questions saying, what if you want to move your object after they're going to tell you like there's a company that wants to move their object after 30 days to a cost saving class, this kind of stuff. This is where lifecycle rules can help. And last thing about versioning is that also this one can happen a lot in the exam. It supports MFA, which is multi-factor authentication. So in order to delete an object, you can add the multi-factor authentication, which means you have like an extra step of security in order to delete an object. Now let's go through the storage classes. You need to know at least all the names and their use case. That's what I like summarized here. And you also have to remember that all classes has 99.99% of availability and 11/9 of durability, except for one class, which is the one zone infrequent access, which has 99.5% of availability and same durability. So the standard class is replicated in at least 3 availability zone as all the others, and the use case is the most generic use case. So this is like suitable for like most of use cases and workloads, usually for websites, storing images, this kind of stuff. So I would say 90% of the use cases is for the standard class. Then we have standard infrequent access class, which is for infrequent access data. So here they're gonna pay a little bit less for the storage, and this can be useful for data recovery, to store like your data recovery backups and these kind of files that usually are not like frequently accessed. Then we have a very similar class, which is the one zone infrequent access class, which is like again for long-term but not critical data. So in this case is for data that you can basically replicate or that are not critical for your application or for your product. Because here the one zone infrequent access means it's replicated only in one availability zone. Then we have Glacier. Glacier is for long-term data archiving. Maybe you need this data like occasionally, so you can wait like minutes or hours. You're gonna pay a retrieve fee, and remember that there are like different classes of Glacier. You can have the expedite one, which is between 1 to 5 minutes. Then you have the standard one, and then you have the bulk one. Standard goes between like 3-5 hours of retrieving time, and the other ones goes up to 12 hours. Then we have Glacier Deep Archive, which is for data which again are rarely accessed. So this is more for like data that you need to store for regulatory purposes. Maybe you need some document, or you need your customer to sign papers, but you never use these papers, just for again regulatory purposes. And you can wait up to 12 hours to retrieve this file. So let's say there is like addition on your product. You can tell the auditor to wait 1 day to retrieve your data. This is the use case for this class. Then we have intelligent tiering, which is basically a new class that AWS added on the S3 service. This is powered by machine learning algorithm, and it basically is for unpredictable workloads, meaning that AWS will figure out, like it's gonna run this algorithm and figure out which is the best class for this bucket for you. So I would say in your exam, if you see like unpredictable workload, this keyword, intelligent tiering is the best option. Now let's move to like the concept of the security of a bucket. As we said, a bucket is private by default. So when you create a bucket, it's not accessible like publicly, but you can of course make a bucket public accessible using bucket policy. I also show this in a video. Basically, you go on the bucket policy and you add the NIM role saying all the objects of this bucket are publicly accessible. If you want like a fine-grained control on your object inside the bucket, you can use ACL, which are like access control list. Another subject you will be tested on the exam is the encryption of a bucket. So S3 has different type of encryption. So in transit is the classic SSL, TLS, and HTTPS. Then at rest we have server-side encryption, which has 3 different values. So it's SSC S3, meaning S3 is going to provide the encryption key for you. Then you can have the KMS, which is basically using a key on the key management store of AWS. So basically this is key managed by AWS, by the KMS service. And then you have SSE which basically C stands for client or for customer, meaning you provide the key that you want to use for the server-side encryption. Then if you want to add an extra layer of security, you can enforce a policy that, like, on the header of the put request, so when you upload a file, the request must contain a header saying x-amz server-side encryption, so you know that the upload is encrypted. And then we also have, of course, the client-side encryption, meaning you encrypt the files before uploading them, and then you upload only encrypted file. Bucket performance. So here is you need to remember this value, because maybe you're gonna have answers asking you about this. So with a use case, and the values are 3,500 requests per second on a put, copy, post, delete request, and 5,500 requests per second for a get and a head. And remember, this is for each prefix, meaning that if you have a file on, let's say, on the root of your bucket, this is gonna be for the file. But if you add folders, like for example, folder, let's say, my bucket / folder 1 / images / your images, the / folder 1 / images is the prefix. So on that prefix, you have those value. And then on another folder, you're going to have the same value. So if you have different prefix, you can basically multiply these limits by the number of prefixes that you have. Remember that you have to use, so AWS suggests to use multi-party upload when files are, let's say, bigger than 100 megabytes in size, and is mandatory for file bigger than 5 gigabytes. You can also use this feature when you download file. It's called S3 byte range. You just have to remember this name if it comes up on the exam. Then we have a new feature. This is one of the latest features that they have uploaded on S3, and is the object lock. This is for use cases where you write once and read many policy, which is also has this warm acronym. And basically the idea is that you store an object without modifying it. And we have two different mode. There is governance mode, which basically user can modify or delete objects unless they have special permissions. And the compliance mode is nobody can modify the objects, not even the root user of your AWS account. Then we have a similar one for the S3 Glacier Vault lock, which basically can enforce compliance on S3 Glacier Vault. And once it's locked, the policy can be changed. So this is the summary document that I've created for the exam. As I said, I'm gonna share it on my Twitter account. So now let's have some fun with these AWS exam questions. There are 20 of them. So I'm gonna go through all of them and see how we can, read those questions, and I'm gonna help you on figure out some keywords and some tips and tricks to rule out some answers. Let's start from the first one. What is the durability of the S3 standard class? So in this case, it's very easy. You need to learn it, and that's it, to memorize this value. And it's 11 nines, which is answer D. Durability is the same for each of the classes, so it's easy. And as we've seen on the document that I've prepared, all classes have 11 nines durability, except one, which is this one. But anyway, you still have 11 nines of durability for the one zone infrequent access class. Let's now read the second one. So an application is generating a log file every 5 minutes. The log file is not critical, so remember this, not critical, but may be required only for verification in case of some major issue. The file should be accessible over the internet. Which of the below mentioned option is the best possible storage solution for it? AWS S3, Glacier, RDS, S3, infrequent access one zone. So we can easily delete RDS, it's like a database solution, and Glacier because you need you have like retrieval fee, and you also the file is not immediately accessible. You need to wait some minutes. So in this case, I'm gonna go through. I'm kind of not sure about S3 or S3 one zone, but since it here is mentioning best possible storage, I will go with S3, which is the general solution for storage like a file. And I think this is the correct answer. Then next one, which of the below mentioned options could be a good use case for storing content in AWS S3 infrequent access? So here is saying, okay, the class is the infrequent access class, storing mission critical data files, storing infrequently used log files, storing a video file which is not reproducible, storing backups. So here, I think the best option is the this one, the B, because it mentioned like infrequently used log files. And as we know, S3 infrequent access is exactly for this use case. Even option D was a good option, but among those, the option B is the best one. Okay, let's move to the next one. An application have to upload and download files. Files older than 2 years will be accessed less frequently. How can we ensure that the application can scale to any number of files while maintaining high availability and durability? Okay, so we have this application with files that and then we have files older than 2 years will be accessed less frequently. So here is saying install the files on Amazon S3 with a life policy, moves object older than 2 years to S3 standard. This seems like a very good option. The other ones mention EFS, which is not a good option for storing files. Elastic Block Store, no. Okay, the other ones doesn't make sense at all. So the answer here is an easy one, which is the first one. It's actually a perfect answer because it's saying we use a lifecycle policy that moves the objects older than 2 years to a cheaper class, which is the infrequent access class. Great, so the answer is the first one. Next one, which is the most cost-effective storage option for a service that provides offsite backups for different devices and has to support millions of customers, in which the images will be retrieved frequently but must be available for retrieval free. So okay, here is again, you need to figure out, you need to, highlight this one, infrequently but must be available for retrieval immediately. So here it's an easy one. We can exclude EFS, doesn't make sense. Glacier is not immediate. S3 standard can be an option, but here the best option is the first one because it's like infrequent access, and the infrequent access class has immediate retrieval feature. So this is the best option in terms of cost and features. So answer number one, easy. Next one, an application that stores images on Amazon S3, processes them with AWS Lambda to add graphical elements. Okay. The processed images need to be available for users to download for 30 days, after which time they can be deleted. Processed images can be easily recreated from original images. Okay. The original images need to be available for 30 days and be accessible within 24 hours for another 90 days. Which combination of the Amazon S3 storage classes is the most cost effective? Okay, cool. So in this case, for sure, we're looking for lifecycle rules because we want to change based on the time that images can be stored. So let's go through the answers. Store the original images in standard for 30 days. Transition to Glacier for 90 days, then expire the data. This seems like a fair option. Oh, we have to select two here, so this can be a good one. Store the images on standard IA, sorry. Then it says deep archive. I will exclude this one. Store the process images on one zone IA and then expire the data after 30 days. No, because it has to be accessible for another 90 days. Store the images standard 30 days. Transition to deep archive for 90 days, then expire the data. This can be another good option because Deep Archive can give you back the files within 24 hours. Actually, it's up to 12 hours. So this can be another good one. Store the processor storage installed and then transition to Glacier after 30 days. Yes, but here this one can be good, but it doesn't expire the data. So we'll go with answer 4, which is standard for 30 days, and then deep archive for 90, and then expire the data, and answer 1. Let me check because I have the answers on my notebook, and it's saying yes, it's the correct one. Perfect. Okay, let's move to the next one. We need to backup some application logs files to Amazon S3. It is unknown how often the logs will be accessed. Okay, this unknown keyword is important, or which logs will be accessed the most, but we must keep cost as low as possible, blah, blah, blah. So in this case, we have the keywords. The keyword is unknown. We have to go with the S3 intelligent tiering. And as I said, the solution was here actually. I think I forgot to delete it. But yeah, S3 intelligent tiering is for when you don't know the workload. So this is the best option we have. All right. All right, question 9. A team is planning to run analytics jobs on log files each day and require a storage solution for only 24 hours. The size and number of logs is unknown. What is the most cost-effective solution? So in this case, we have running logs. So Glacier Deep Archive is excluded. Intelligent tiering, we don't know. S3 standard can be an option again. So I'm not sure about second or third option, but I think I will go with the S3 standard option in this case, since we're deleting the files after 24 hours, so it doesn't make sense to have intelligent tiering. And I think option 3 is the best option for this use case. Let me check the solution I have on my notebook. Yes, option 3 is the best one. Perfect. A company stores important data in Amazon S3 bucket. A solution architect needs to ensure that data can be recovered in case of accidental deletion. Okay, so that's easy. We need to be sure that in case of accidental deletion, we have the file. So what can you think about it? The only option here, we need to check and answer with versioning. So easy. With versioning, we can have different versions of the file and also having the deletion marker. So in this case, the answer is answer number 4. And if you want to understand better what is the versioning on S3, I'm gonna leave a video. I'm gonna leave a video where I explain this on the description. Next question is, a document submission application will use an Amazon S3 bucket for storage. The solution must prevent accidental deletion for the document and ensure the old version of the file are available. Okay, again, we need to prevent accidental deletion, and also ensure that all versions are available. User must be able to upload and modify documents. We need to select 2 combination actions. So I will say we need to find versioning and also MFA. So in this case, MFA in order to ensure that we prevent accidental deletion and also enable versioning for having all the version enabled. So in this case, it was an easy one. Answer 2 and 4. The other ones, encryption doesn't make sense. Attach IAM policy doesn't make sense at all, and read only doesn't make sense. It's also saying be able to upload, so read only really doesn't make sense at all. Next question. A higher scalable system contains records that must remain available for immediate download for 3 months, and then the records must be deleted. What's the most appropriate decision for this use case? So again, here I will look for an answer with lifecycle rules. First is Amazon ABS, doesn't make sense at all. Glacier doesn't make sense because we need immediate download. Here the answer is it's easy, S3, and then create a lifecycle policy to remove the file after 3 months. So answer number 3. These was an easy questions, because all the other services were not useful for the use case. Next one is an application that receives and processes files with size around 4 gigabytes, extracts metadata from the files, which typically takes a few seconds for each file. The pattern of updates is highly dynamic, with times of little activity and then multiple uploads within a short period of time. What architecture will address this workload the most cost efficiently? So it seems like the pattern is unknown. So we'll look for an S3 option and then like having, some service to modify the file, which is going to be Lambda, I guess. So here is saying store the files in EBS, then can be accessed from, this can work, but it has like high maintenance cost. It's not, let's say, a serverless option. This is upload S3 backend, use Amazon S3 event notification to invoke a Lambda function. This can be, I think this is the best answer really. It's everything serverless. You have Lambda invoked by an event notification from S3, which is great. Place the file into SQS queue and use a fleet. These are all viable options, but they're not cost efficiently. And so, yeah, as I said, the best option is this one because it scales automatically, and based on the amount of files that we have, Lambda function will be called. So answer number 2 is the best for this one. Next one is a website developer using HTML, CSS, client-side JavaScript, and images needs to be hosted. Which solution is the most cost-effective? So we know that S3 can host websites, so we're going to look for an answer containing S3. Containerize website and host it in AWS Fargate. This can work, but is expensive. This is a very good option. Amazon S3 backend and host the website there. Deploy a web server on Amazon EC2 also works, and also this one works, but they're overkilled. So I would go with answer 2, and this is the best option. As you said, like in a lot of questions, you have different, working, let's say, answers, but you need to choose the best one, which is in this case, Amazon S3. Solution needs to encrypt data in Amazon S3, okay, and the encryption keys must be generated and managed on premises. So, okay, we need to encrypt and we need to manage the key on our side. Which solution should be used to meet the security requirements? In this case, we know there are different types of server-side encryption, and we want to be able to manage the key. So, option 2, we need to find the SSC. I was saying SSC-C option, which is option number 2. Remember the C stands for customer, so here is the customer providing the encryption keys. So you have to remember these 3 classes of SSC. There's nothing you can do, and then you got the answer. So answer number 2 is the right one. Let me double check, but yeah, it's the correct one. Cool. Next one, and then we only have 4 left, and then trust me, we're done. Some images must be encrypted at rest in Amazon S3, okay, but the company doesn't want to spend time managing and rotating the keys. So this is a similar use case as before, but in this case, the company doesn't want to handle the keys, although this company wants to control who can access those keys. Okay, what should a solution architect use to accomplish this? So in this case, we can't use SSC-C, which is in this because, as we said, is the customer providing the key, but we can use KMS, which basically uses the key management service of AWS, where you can basically create roles on who can control those keys. So the answer is the number 4, where you use AWS KMS. Okay, next one. A new security mandate requires that all the personal data held in the cloud is encrypted at rest. Which 2 methods allow you to encrypt data stored in S3 buckets at rest cost efficiently? Okay. Select 2. This is like a multiple answer question. Make use of AWS S3 policies this doesn't make sense because it doesn't encrypt the data. Use S3 server-side encryption with key management service. So this can be an option. So option number 2 for sure. Cloud HSM doesn't make sense at all. Encrypt the data at the source using the client CMK, customer managed key, before transferring to S3. Use multi-party upload. This is for encryption in transit though. So the options are option 2 and option 4. Because here we're encrypting the data at source before uploading, and here we are encrypting the data at rest once they've been uploaded on the S3 bucket. Perfect. A data lake solution in Amazon S3 makes infrequent SQL queries only. A data lake solution in Amazon S3 makes infrequent SQL queries only. Which AWS service should be used to minimize infrastructure cost? Okay, I think I haven't mentioned this, but the service here is Amazon Athena, which basically lets you run SQL queries on Amazon S3 buckets. So you don't need to know all the details about Athena, but at least have a look on the presentation page of the service. It's used for running SQL queries on S3 buckets. And it's a serverless solution, so you don't need to spin up any server. Okay. A solution architect must design a storage solution for incoming billing reports in CSV format. The data will be analyzed infrequently and discarded after 30 days. Which combination of services will be most cost effective, so important, most cost effective in meeting these requirements? Write the files to S3 and use Amazon Athena to query the data. Can be an option. Import the logs to Amazon Redshift cluster. This is not an option because it's it's for analytics, but on huge files. Use data pipeline to import logs into this. Doesn't make sense because it just uploads basically files on DynamoDB tables. Import the logs into RDS. RDS is a database solution, so I will go with answer number 1, which is write the files to an S3 bucket. That's it. And then you can analyze that using Amazon Athena. Let me check. Yes, it's the correct one. And that's it. These are all the questions. I hope these sessions were useful. If you have any questions, please let me know in the comments. And thanks again for watching this video.